So review of logarithms. So when we're solving a logarithm, for example, if we have the log of base 3 of 9, we're really searching for an exponent. So LOG is the abbreviation for logarithm. And logarithm implies we're searching for the exponent. So when we see something like this, what we want to think in our mind is we want to think, what is the exponent or logarithm of base 3 that gets us 9? And since 3 squared equals 9, the 2 is the exponent that we're looking for. So the other way that we could do this problem is we can do what's called convert to exponential form. So let's assume that we don't know what this expression is equal to. So then we could set it equal to, let's just say, x. And how we convert to exponential form in class, I called it like this loop-de-loop method. So what you do is you start with the base and you loop it to the other side of the equation. And that gives you 3 to the x power. And then I say loop-de-loop equals 9. So you're working in a counterclockwise direction, starting with the base. And if you looked at this equation, then maybe it would be more apparent to you that x would have to be 2. Right? So we get the same exact answer this way. Okay, so let's try a new problem, and we'll do it both ways. We'll just do it thinking about it, and then we'll do it by converting to exponential form. So let's just say that I had, for question 2, I had LOG. I'm going to say my base is 5. This is 125, right? So in words, we could say in our mind, what is the exponent of base 5 that gets us 125, right? So then some of you might know the answer to that question. 5 to the third power gives us 125, so the exponent is 3. Okay, so alternatively, what we can do is we can take this expression, and assuming that we didn't know that it was equal to 3, we could set it equal to, let's just say, x, and then once again convert to exponential form. So we start with the base, we loop it to the other side, that gives us 5 to the x, loop-de-loop, equals 125. You can even do common base equations here, right? 125 is 5 to the third power, and therefore x has to be 3, right? So we get that same 3. All right. Question 3. So let's just say I had to figure out what the log, and then you just saw a 10 next to it. So in this situation, I'm not actually given the base, right? Usually there's something right here. So when a base isn't present, we assume to be 10. So we would be looking for what is the exponent of base 10 that gives us 10. And hopefully we would know that that is 1, right? And that's because 10 to the first power gives us 10. Question 4. So we also learned another way to notate a logarithm, a very special logarithm actually, and that's with the ln notation. I'm using a cursive L because sometimes my regular L's look like a 1, so that's why probably cursive is better. So let's just say that we had ln of e is another number that we learned about. So the ln symbolism stands for log base e, which e is another constant that's irrational, very similar to pi, although it has a value a little bit smaller than pi. Pi is 3.14, etc., and e is roughly about 2.7-ish. So ln represents log with this very special base of e, and just keep in mind that we still have this e to bring down as well. Right? So let's try to answer this one. So what is the exponent of base e that gives us e? Well, I think likewise, just like the last one, this is going to be 1, right? E to the first power gives us e. So in the next series of examples, we're just going to practice going to exponential form. So after writing down these problems, it might be a good idea to pause the video, see if you can convert to exponential form, and then continue the video to see if you're correct. So some of these are just going to be very general, and I'm just going to use letters in some of them. Okay, so let's practice converting to exponential form. So in the first one, my setup is already good. I can see the base. So we start with the base, we loop it to the other side. So this is a to the c power equals b. In the second one, I don't see a base, so that's when we want to recall that if we don't see the base, it's assumed to be 10. So now we'll do our exponential. So we circle the base, we loop it to the other side. So 10 to the third equals x. Right? And for this last one, so when you see the ln notation and you want to go to exponential form, you want to rewrite that ln notation as log base e. Okay? And then you copy and paste the rest of the equation. And then you can go to exponential form. Right? So we're going to circle the base, loop it to the other side. So we're going to get e to the x equals, and then 4. Right? Not having you solve anything for these, I just wanted you to practice converting to exponential form.